Welcome, traveller of the stars. You've arrived at the Infinite Scientist, where science dreams in the language of the cosmos. Tonight, we follow the path of something infinitely small but endlessly mysterious, the particle that dreamed of being two. If you find beauty in the mysteries of the universe, let your curiosity rest here. Subscribe and dream with us beneath the stars. Far from the reach of our senses, in a world too small to touch, there moves a particle, not in the way a ball rolls or a ship sails, but in the way ideas drift before turning to thought. You cannot see it pass. You might not notice it's there at all. Yet it is everywhere things begin. In the shimmer of a star, in the whisper between atoms, in the light dancing between your eyelashes right now. This lone particle moves not with certainty, but with suggestion. It does not claim a path. Rather, it casts its presence like a net over all that could be, until one moment, one act of attention, causes it to fold in on itself, like a wave that suddenly remembers it is water. This isn't fantasy. It's quantum physics. And everything about it presses gently against the edge of logic. The experiment is almost childlike in its simplicity. A beam of light, a barrier, and two narrow slits carved cleanly through. You send particles, single photons, one at a time, hurtling toward this wall, expecting them, like good little messengers, to choose a side. Pass through the left slit, or the right.
That's what we expect, but reality, it seems, has a different rhythm. Because when the light is allowed to pass, when we don't interfere,
don't observe, don't demand an answer, the photons forget they are particles entirely. They behave not like single bullets, but like overlapping waves, rippling out, curving through both slits at once, creating a soft interference pattern behind them. It is as though each particle has interfered with itself, as if it passed through both slits simultaneously. But how?
How can a single thing travel two paths at once?
When no one is looking, the quantum world behaves like possibility. It does not decide where to be until presence, conscious or not, demands a location. And when that happens, it answers the question with finality. We fire the photon again, this time setting up detectors to measure which slit it passed through. And suddenly the dream ends. No more ghostly pattern.
No more waves.
Just two solid clusters.
Exactly where they're supposed to be. It's
almost as if the particle knows it's being watched. It collapses from a swirl of maybes into a single truth. This is called superposition, a core principle of quantum mechanics. Until we observe the outcome, particles exist in multiple states at once. They are not this or that. They are this and that, and neither, and both, like a coin forever spinning in the air. Neither heads nor tails until it lands, or perhaps like a dream not yet remembered. Some interpretations suggest that measuring the particle forces it to choose a path. Others say the wave function, stated the mathematical description of all its possible states, collapses when an outcome is required. And still, more radical ideas whisper of parallel worlds, gently branching off with each possibility. A photon goes left in one universe, right in another. All paths explored.
All destinations real. It is not only wondrous.
It is unsettling, because the very notion of cause and effect, so rigid in our waking experience, begins to stretch. The observer changes the observed, not just in interpretation, but in actuality. This is where the metaphors grow tender, because somehow in all its strangeness the particle reminds us of ourselves,
of the versions we contain,
of the choices we nearly made, of the lives we almost lived. Perhaps we too exist in a kind of superposition until decisions collapse us into timelines. Perhaps the stories we live are only one thread in a quiet tapestry of other selves, drifting just beyond the veil of now. There's something comforting in that, the idea that we are soft, not fixed. That identity, like light, might shimmer between many forms before anchoring into the moment we become. And yet it also brings humility, because the tiniest unit of matter does not move in straight lines. It dances, it hesitates, it waits for your eyes to make it real. So then, what is real? If the act of noticing can sculpt the path of a particle, what else are we shaping simply by allowing ourselves to be here? The double-slit experiment is not merely a scientific puzzle. It is, in a quiet way, a revelation, an invitation to rethink everything we trust: space, certainty, isolation, boundaries. Because the truth is this: reality may not exist until it is touched. The universe, perhaps, is not a thing unfolding independently outside us. It is a conversation, a duet, a shared agreement between matter and mind, that even in silence, the cosmos listens for the sound of your attention, and maybe, just maybe, the particle wasn't dreaming at all. Maybe being two was its nature,
And being one,
was the compromise. Tonight, as you drift away, let this truth find you, that the fabric of the universe is stitched not with absolutes, but with shimmering threads of potential, and every breath you take is part of the pattern. Somewhere in the quiet ink of space, a photon leaves a star. It does not hesitate. It does not pause. It races outward, as if time itself pulled it forward like a thread. And yet, in that unblinking moment between where it was and where it's going, something strange occurs, something rarely spoken outside the language of the quantum. For this light, this particle, this wave, may not simply be arriving. It may be remembering, choosing its entire path from both the destination and the origin all at once. Imagine you're watching a drop of rain fall into an endless, still lake. But instead of ripples spreading outward, they begin at the shorelines, curling inward, converging on where the raindrop is about to land, as if the lake already knew and welcomed its fall with ancient hands. This is not metaphor alone. It echoes a real and uncanny feature of our universe. They call it the delayed choice quantum eraser, a name more suited to a science fiction novel. But it is real, tested, observed, and still not fully understood. The experiment begins like the story we've already told: a photon sent toward a beam splitter, facing choices it does not technically make. Except now the stakes are even stranger, because in this version, a decision to observe or not to observe isn't made ahead of time. It's made after the photon has already passed through. Imagine whispering into the past. The setup is complex, but the effect is simple and staggering. A photon enters the apparatus. Like in the double-slit, it can act as a particle or as a wave. If left unmeasured, it spreads, it dances, it interferes with itself, showing the familiar wave pattern like a song sung in harmony with its own echo. But sometimes the data is manipulated.
after the photon has already done its traveling, after it should have decided who it is.
Only then do we determine whether which path information about that photon can be known. And here's the magic. If that information is knowable, the interference pattern disappears. If it is erased, the pattern returns. But this decision took place after everything should have been over. It is as though the photon, traveling toward its fate, still somehow knew what decision would be made, as though future awareness reached back and whispered to the past, rewriting what already happened. It reminds us of a truth we resist. In the quantum world, cause and effect are sometimes blurred beyond recognition, like a story that writes
Its first word only after knowing its
last. The light doesn't just forget who it is, it waits to be told. And deep within this mystery lies the question.
No one dares speak too loudly. What is time?
We think of time as a sequence, a slow and steady march from yesterday to today to tomorrow. a track laid beneath our feet only as we move forward. But quantum mechanics suggests something very different. It doesn't speak of a clock, but of a landscape, where all times exist at once, sprawled beneath a sunless sky. A photon may not experience time the way we do. In fact, from its perspective, it might not experience time at all. To a photon, born and absorbed, the journey may feel instantaneous. It leaves one atom and arrives at another, and nothing exists between, not even a moment. Perhaps for light, all paths are already chosen because all destinations are already here. And if one small thing outside of time can exist, what else can?
You listening now have built your life on the comfort of story. Beginning, middle, end.
But consider this, maybe some part of you is also quantum. Maybe memories aren't echoes of a fading past. Maybe they're shadows cast from a future you haven't lived yet. Maybe intuition is a kind of echo, a signal your atoms remember, even if your conscious mind can't name it. Science does not yet make room for such thinking. But the quantum field doesn't need permission to behave strangely. It simply does, and while we cannot say definitively that time flows backward, the experiment raises a devastatingly poetic possibility that the present might be shaped not just by what has been, but by what will be. This has no neat explanation, just as dreams have no edges. But what we do know is this: consciousness and measurement can affect the way quantum systems unfold. The very act of choosing determines the behavior of light, retroactively. We cannot hide from that implication. We are not separate from light. We absorb it, we bend it, we see the world with it. Every moment you gaze at the world, you are pulling photons from the past into your retinas. They race across empty space just to become part of your present. And though you cannot feel it, though your skin does not vibrate with the weight of this, you are being written upon by the very code the universe uses to see itself. Every sunset you've ever watched was a story told not in real time, but in echoes, and every echo curls backward through space-time like a message written in light, hoping you'll listen. Which reality will you choose to create by noticing it? Which path among the many will become yours, simply because you cared enough to be present? There is more to understand, much more that slumbers beneath this fabric we call reality. But for now, let this lull you gently, that even light is not always what it seems, that it remembers, that it listens, that in secret it waits not for direction, but for your attention. Float your mind far from the clutter and hum of the ordinary world, to the stillest place you can imagine.
A vast absolute emptiness.
No stars, no gas, no murmurs of time or glimmers of light, just space, void, the immaculate silence between galaxies. A cathedral made not of matter, but absence. Now listen closely, because even here, something is singing. It's easy to imagine that emptiness is nothing, a blank canvas untouched by sound or motion. But in the language of quantum physics, even nothingness is alive. The vacuum, as we once thought of it, the perfect, quiet nothing, does not exist. In its place lives something more electric, more vibrant, and far more mysterious, the quantum vacuum. A field not of emptiness, but of potential. And in it, the universe trembles, constantly, subtly, without rest. When we speak of a vacuum, we usually picture it as a room swept clean of all particles. But the quantum world defies even this. Pull everything away, every atom, every photon, every scrap of matter, and instead of stillness you are left with a storm, fleeting, invisible, eternal. This is space at its most secret. On the smallest scales, within the fabric that makes up all fields, even when nothing is supposedly there, something remarkable occurs. Pairs of particles and antiparticles blink into existence, then vanish again so quickly that they defy the law of conservation, their presence permitted only by a quirk of the Heisenberg uncertainty principle. These are virtual particles, temporary ghosts that dance beneath our knowing. A particle and its mirror, a silent twin, appear, spin, vanish.
Over and over.
Not as real objects, not quite, but as fluctuations in the sea of quantum noise. They arise not from somewhere, but from nothing. Or rather, from the trembling uncertainty built into the fabric of space itself. A vacuum, it turns out, is never at rest. If you could shrink yourself, compress everything that makes you human, down into the realm of Planck scales and hover inside what we once called empty space, you would not find peace. You would find flickers, disruptions, a wild, unending jitter, particles that do not exist in the classical sense, but influence the very nature of everything that does. This vacuum energy has weight. It pushes, it pulls, it shapes the evolution of the cosmos. It's not some aside. It is part of the structure of existence, and in fact, it might hold one of the grandest secrets of all. The expansion of our universe is accelerating. Galaxies are rushing away from each other, and no one fully knows why. But one suspect, whispered like a myth behind equations and chalkboards, is this very vacuum energy, a pressure born of nothing stretching space apart. You are alive within this hum, even now. It billows gently from the void beneath your feet, beneath your atoms, beneath the spaces between the spaces. It carries no color, no sound, no shape. And yet it shapes everything. Stephen Hawking predicted that even black holes are not immune to this unrest. Hawking radiation,
As it's known, emerges from the edges of darkness, from the friction between the vacuum outside the black hole and the impossible gravity within.
when a virtual particle pair appears right at the event horizon, one falls in and the other escapes. The black hole pays for this escape with mass, and over unfathomable epochs, it evaporates. It is the vacuum, the empty nothingness, that slowly erodes the most violent objects in reality. What a delicate irony! Black holes, once thought eternal, may wither not by force or intrusion, but by the gentle, patient whisper of the vacuum that surrounds them. In the quantum world, silence creates structure. But beyond physics, beyond numbers, beyond even the great theories spun by our best minds,
There's something profoundly human in all of this.
because we have feared emptiness since the dawn of thought, we speak of voids the way we speak of death, as absence, as loss, as loneliness. But what if it's the opposite? What if even nothing is alive? What if the things you call empty, the room after someone leaves, the night sky without stars, the pause between notes in a melody, are not lacking, but full of something only quiet can reveal? The vacuum is the birthplace of beginnings. The particle arises from silence. The photon dances into being not from structure, but from chaos and chance. Perhaps your mind works the same way. Perhaps your thoughts, the ones that come uncalled in the dark, are made not of language and logic, but of fluctuations within your own awareness, like particles appearing briefly in the stillness of your soul, shaping your reality before they vanish again. It's humbling to imagine that the same uncertainty causing quantum foam to flicker beneath space is also what lets beauty, insight, and memory rise up within you. And even more humbling, that we might never hear the full song of the vacuum, only its echoes in the way galaxies drift and black holes die. So as you rest tonight,
Lay your thoughts into the spaces between things.
trust that nothingness is not lifeless, that silence is not still. For in the unseen corners of everywhere something stirs, and in the places you once thought empty, the universe is quietly humming. It begins with something simple. you rest your hand on a table, solid, dependable, still. You touch a wall and it resists you. You knock on wood and it knocks back. Reality, it seems, is firm.
Objects are objects.
You and the world are made of matter shaped into meanings. This is what your senses teach you, what your whole body insists must be true. But below that familiar surface, the quantum world is stirring, and what lies beneath the skin of reality is not solid at all. Zoom in close enough, closer than close, deeper than any microscope can see, and you will find that the table isn't solid,
Nor is your hand.
nor is anything you've ever known. Atoms form the illusion of firmness, arrayed in repeating patterns. They're electrons floating not in orbits but in probabilities, clouds of maybes, smeared around unseen cores. Most of what we call matter is emptiness. The gap between particles is vast, proportionally more space than substance.
And the particles themselves?
Point-like, without true volume,
Flickering into and out of the quantum fields they ride. It's not that matter doesn't exist. It's that it is not what we
imagine electrons don't follow little tracks around atomic nuclei like planets around a sun. There are no lines. There are only chances, possibilities, waveforms, a strange mathematics of where a thing might be if it chooses, if it resolves, if it collapses into being upon observation. Until then, it remains uncommitted, a whisper on the surface of the void. These are superpositions again, yes, but now not just in exotic labs or distant galaxies. This is everything. Your coffee cup, your lungs, the ground beneath your feet. Beneath their skin is a formlessness pretending to be form, a chorus of vibrations emerging from invisible fields, ruled by uncertainty and shaped by unseen rhythms. Fields, not particles. This is where quantum physics now leads us. According to quantum field theory, every kind of particle is an excitation, a little ripple within a broader field that stretches across all of space-time. There is an electron field, a photon field, a quark field. These fields aren't located in particular places. They are everywhere. When a particle appears, it is not so much that something becomes, but rather that something ripples into awareness, like a wave passing through an otherwise still sea. And then, form not stone, not steel, but vibration locked into patterns so subtly that they become what you call objects. Reality is not a structure. It is a song, a composition of wave functions overlapping and echoing. And we are melodies born from this deep music, complex, layered, emergent, but never separate from the field that sings us into place. Perhaps this is why nothing stays still. Even when you rest your hand on a table, the atoms never stop moving. Electrons flit about with impossible speeds inside their clouds.
Even at absolute zero, the coldest temperature theoretically possible, particles still jitter, refusing to be perfectly still.
This is called zero-point energy, and it is yet another reminder that stillness is not real here. Even the deepest sleep of matter contains motion. At the tiniest scale, under Planck-length scrutiny, space-time itself may not be smooth but foamy, bubbling, seething, erupting constantly with strange topology, wormholes, fragments, loops. We cannot yet observe this directly, but the math warns us. Our understanding of space is a projection, a softened image of a chaos we cannot yet measure, and yet, out of this chaos order. Somehow the world assembles itself from all this incompleteness. The particles stabilize into atoms, the atoms share electrons into molecules, and molecules build you, a breathing, thinking, curious observer woven from uncertainty. And what decides the shape of the final form? Probability. Nothing in quantum physics predicts a single, guaranteed outcome. It gives us patterns, chances, stains of likelihood. It says, here is where the particle is most likely to appear. Here is how this ripple will probably behave.
Never certainty.
Always softness. So what then is reality? A tapestry sewn from the threads of what usually happens, but never from what must. Some physicists suggest that what you call classical reality, the solid, practical world of cars and clocks and coffee shops, is simply the quantum world averaged out, a consensus between the chaos and the observer, between all the possible worlds, blurred into one persistent illusion. You are not touching things. You are interacting with fields whose force carriers create resistance. Whatever you feel you do not truly touch, and yet the illusion is complete, so complete, you forget how delicate it really is. But remembering this, remembering that beneath every surface lies a shivering chorus of quantum uncertainty, can make your world feel gentle again.
Not rigid, not cold, but alive. Every wall you lean against.
Every glass you hold. Every part of your body that feels firm and real. They are not static objects. They are waves interlocking.
For a moment, for now.
For this little dance of attention, what's beneath the skin of reality? Nothing solid, nothing certain, only a field of possibility, vibrating with perhaps. And that may be what makes it beautiful. So as you rest tonight, imagine the room around you not as walls, not as floors, but as gentle waves in dark water.
Everything shifting.
Everything adapting. Everything singing some ancient song just for you, and you, not quite separate, not quite whole, listening. There is a pause, a quiet hanging in the air before anything begins. Not a silence born of nothing, but a fullness too complex to move.
Attention.
A waiting. This is the world before the world, not a heaven above or a void below, but a strange, weightless place where nothing is fixed and everything is leaning toward becoming. A realm where existence itself sits just beyond reach, balanced on the edge of a coin that hasn't yet landed. This is the space where probabilities bloom. The everyday mind doesn't dwell here. It cannot. We are wired to love facts, outcomes, answers. We are built to ask, what is? But in the quantum layer of the universe, the root behind the roots, the real question is never what is, but what might be, because here the universe is not made of things, it is made of chances. Particles don't live in one place. They are more like whispers stretched across entire possibilities, existing in states not of being, but of perhaps being. The future is not waiting ahead on a single road, but branching infinitely in a rural tangle of maybe, maybe not. This dance of uncertainty is held together by a single mathematical spell, the wave function. The wave function is not just a number. It is not just a line scribbled by a physicist into a chalkboard storm.
No, it is the dream of the particle before it wakes.
It is the soft, unspoken language by which the quantum world speaks everything into something. It tells us all the places a particle might be, all the ways a world could unfold, and how likely each path might be chosen. Until, suddenly, it is observed, and collapses, one outcome, one truth, and the rest
Gone, not in failure, not in error,
but gracefully declined by existence itself. The wave function is a spell we are still learning to read. Some believe it's merely a tool, a way for us to keep track of odds.
Others believe it is real, the reality, and everything we witness is just the shadow cast by its sudden collapse. But this collapse is where mystery deepens, because what causes it?
In all our intricate math and deepening experiments, we still do not truly know.
Is it the act of measuring, me literally poking the particle and forcing a response?
Is it consciousness, awareness flooding the system and turning haze into clarity? Is it something we do not yet have the language to name? There is, for now, only wonder. Systems interact, and the outcome becomes definite. A particle that could have been here, or here, or here decides. Not with agency, perhaps, not with thought, but with obedience to something more ancient. Once, not long ago, the mind wanted reality to be like a machine. Clockwork laws, pure cause and effect, neat outcomes. But quantum physics does not follow Newton's logic. It flows closer to poetry. It offers not certainties, but songs of symmetry, interference, and chance. The universe is less a ticking clock than a sleeping symphony, and we, the quiet audience waiting for one note, just one, to awaken us. Still, the probabilities within the wave function are not random chaos. They shimmer with structure, patterns, rules, interference. Just as certain notes cancel or amplify in a sound wave, quantum probabilities observe discrete laws of rhythm. Some futures clash and fade, others harmonize and pulse with likelihood. This is quantum interference, and it's one reason why the particle behaves like a wave in the famous double-slit experiment. Its probability flows overlap, cancelling in some places, building in others, crafting that mysterious ripple pattern on the far wall. It means the particle is speaking a language more evocative than here or there. It's saying, maybe both. It's composing patterns from possibility. And here, within the repetition of chance, meaning begins to rise. Because the longer we listen to the mathematics of quantum mechanics, the more it sounds like something we've always felt about living, that the future is plastic, malleable, and alight with unseen doors, that the outcome of this moment is never guaranteed but gently influenced by presence, by attention, by the invisible weight of all that could be. What does that make you?
A witness, a shaper.
A question the universe cannot ignore. You do not just exist within this soft unfolding of probabilities. You belong to it.
Harmonize with it.
Every thought, every decision, every small action collapses one path of being and leaves the others behind like footprints on paths you almost walked. The truth is stranger than space, softer than thought. It is stitched from insistent maybes, woven only when you dare to stand still enough to call it into form. And perhaps this is not just a description of quantum behavior, but of your life itself. That everything you build is made of things that were once uncertain, that your memories, your identity, your being, all of it, comes not from a single push, but from countless gentle leanings,
until one became you. So take comfort tonight in the
strange logic of the wave function. What seems uncertain is not lost. It is full of potential, and what is soft is not weak. It is the space in which all strength is born. As you close your eyes now, let the maybes fold gently around you. And know this: the world is not made of stone. It is made of possibilities softly collapsing into truth, and every breath you take is a choice the universe agreed to make. In a quiet room, suspended beyond time, a box sits unopened. It is perfectly still. Lid sealed. No sounds stir from within. No trembling of paws or motion in the air.
only silence, and yet inside that box there may be life.
Or there may be death, or in a way unsettling and vast there may be both at once. This is not a riddle to be solved. It is a mirror held up to the strangeness of the quantum world and to us. The image was first imagined in 1935, not as an answer, but as a provocation, a puzzle. Erwin Schrödinger, one of quantum theory's founding minds, proposed it not to explain quantum weirdness, but to expose it. He wanted the world to see just how absurd things had become, and yet in his absurdity he held a key to deeper understanding. The idea was simple and chilling. Suppose, Schrödinger said, inside the closed box lives a cat, with it a Geiger counter,
a vial of poison, and one single atom.
That atom, due to radioactive decay, has a 50-50 chance of breaking down sometime within the hour. If it decays, the detector triggers, shattering the vial, releasing the poison. The cat dies, if the atom stays intact, the cat lives. Now close the box. Walk away and ask yourself this: what exists inside? According to classical logic, the cat is in one of two states. It is alive or it is not. But in quantum logic, the atom is in superposition. It has decayed and not decayed. It is caught within a cloud of probabilities that has not yet resolved. And since the life of the cat is tied to the fate of the atom, does that not mean the cat too is in superposition, dead and not dead, asleep in both states, waiting for the observer to look, waiting for reality to choose? Not until the box is opened, until the system is measured, does one path crystallize, one wave function collapses, one truth arrives. Until then, there is only one certainty: uncertainty itself. In reality, of course, cats are not quantum systems, and macro-sized things like feline bodies are made from trillions of particles that decohere far too quickly to remain suspended in superposed states. But Schrödinger wasn't talking about real cats. He was talking about something more delicate. He was talking about the absurd poetry of observation. Where does the quantum world end and the classical one begin? How far does the uncertainty reach? And at what point does the system stop dancing with all possibility and settle into a single shape? Some physicists argue the act of measurement doesn't require human consciousness, only interaction, a photon bouncing off a surface, a particle colliding with another. Some say that a detector is enough. Some say only the mind can collapse the wave. Others whisper that all outcomes are real, everyone, and we simply slide into the universe that
matches our observed version. This is the many worlds
interpretation, where the cat lives in one universe and dies in another, and both universes carry on, unaware of the other's breath. In that view,
every choice you make forks the sky.
And yet, even if we never know which idea is true, something stays with us from the image of the box, that maybe certainty itself is limited, that beneath the surfaces we rely upon, simple labels like yes or no,
open or closed, there is a realm of maybe.
A softness to reality that frightens us as much as it frees us. We want boxes to open cleanly. We want answers. But quantum mechanics offers us something else: the humility of waiting, the patience of containing mystery,
and the audacity to hold two opposites in one breath. There is something deeply human in that. Haven't we all at times been both things?
Both brave and terrified, both grieving and grateful, both leaving and wanting to stay. Each of us is a sort of Schrödinger's self, a being made of maybes, until some action, some choice, splits the road behind us and leaves only the steps we took. And even then, some part of us remembers the other self that might have been. Reality is not a chain of definite events, but a wave field of suspended currents, where what we call facts are merely crystallizations of a deeper, invisible tide. And for the cat in the box, for us all, existence itself might be less about being and more about becoming. This is not an argument about animal rights or physics alone. It is about the strange and gentle truth residing at the very edge of awareness, that the act of seeing transforms the seen. Not because vision is magic, but because perception is participation. Every time you bear witness to suffering, to beauty, to change, you collapse something weightless into something real. You plant one flag among thousands of invisible options, and by doing so, you create the story. Before the box is opened, before that final opening, there remains a beautiful grace in unknowing. In the stillness, the cat is neither alive nor dead, or both, or something else, a metaphor for what it means to dwell within possibility. And so, tonight, let this paradox cradle you gently, like a question without an answer. Let your thoughts become like particles unmeasured. Let yourself exist between the versions you have been
and the one you may become. Know that you too are more than one outcome, and sometimes
The most profound truths are not those we uncover, but those we allow to remain asleep in silence, like Schrödinger's cat, waiting behind the lid of time for the moment you choose to finally look. Somewhere in the quiet machinery of the cosmos, a door opens, not with the screech of hinges or the pressure of force, but with the simplest act of being seen. No hand turns the lock. No voice calls from the other side. It is opened by observation. It is opened by you. This is one of the most hauntingly beautiful ideas of quantum physics, that reality does not reveal itself fully on its own, that the universe, far from being an indifferent machine, might behave differently simply because you're watching. It begins, as many quantum stories do, with light.
A single photon.
A wave and a particle, depending not on some intrinsic secret, but on how we choose to observe it. We return here again to the double-slit experiment. Simple, elegant, infinitely strange. A single particle passes through two slits. If unobserved, it behaves like a wave, creates an interference pattern. But when we place detectors at the slits, daring to know which path it took, that ghostly pattern collapses. The photon does not act as a wave anymore.
It chooses a slit, chooses a path.
Collapses into a fixed point, just because we watched. It is as though the universe adjusted itself around our gaze, aligning to the very question we asked, not in deception or illusion, but in cooperation. In quantum mechanics, this is inseparable from the concept of measurement. In this realm, observation is not passive, it is interaction. It is the moment when potential becomes particular, when the hazy cloud of all possible outcomes collapses into the one that becomes experience. Watch, and something happens. Don't watch, and something else happens, as if your question is the key to the door. What happens to the universe if no one is watching? It's not just philosophical, it's deeply physical. At these smallest levels, electrons, photons, the smallest quanta of being, nothing is decided until measured. Nothing is fixed until witnessed. We call it the measurement problem, a name that feels too clinical for such a profound implication because it hints that reality and awareness are intertwined in a way we do not fully understand. That seeing isn't just receiving, it's shaping. There is a faint sadness here, a soft, melancholic awe, because we grow up being told the universe is indifferent, that it moves with brutal efficiency through laws we cannot change, that it is external, hard-edged and complete without us. But quantum physics offers something gentler, more intimate and far more unsettling, that you, not just as a body or a brain, but as a presence, are part of the universe's unfolding, that your observation doesn't merely tell the story, it helps write it. There are theories that chase metaphors through equations. In consciousness-based interpretations, it is awareness that collapses the wave function, that the very act of knowing finalizes the event. In others, it's not minds that matter, but interaction. Any interaction with any system that transfers information and irreversibly pushes quantum uncertainty into classical certainty. Either way, something changes the moment we ask the universe to show itself. Reality is participatory. This is not to say that the universe needs humans to function. Far from it. The cosmos was here long before we opened our eyes. But what quantum mechanics implies is that the version of reality we touch, interpret, experience, that layer of it we call real, may not take shape until we reach out. It is like a poem that only completes itself when read, or a star that only burns for those who notice the
light. You are not just adrift in this ocean of existence.
You are shaping its waves. We are so used to dividing the world into subject and object, observer and observed. But in the quantum world, the line between those two begins to dissolve. The photon senses the curiosity of the experiment. The electron does not lock its position until position is asked of it. There is no passive witness, there are only participants. Physics does not say what lies beneath this strange dance. It offers math, predictions, models, but not motive.
Not why, and yet it opens a door, however slightly, toward the idea that consciousness, or something like it, might not be separate from the universe,
but emergent from it, not imposed upon matter, but stitched into the very same fields that give rise to space and time, and if that's true, even just a little, then attention
becomes the most sacred force we possess. What
we choose to see changes what is. It is easy to forget this, easy to feel small, disconnected, a speck in the star river of the cosmos. But quantum physics tells another story, a quiet rebellion against disconnection. That looking is a kind of creation, and maybe that's why stories matter, not because they change what happened, but because they shape the world that becomes in their telling. In your life,
how many moments only felt real after you remembered them? After you shared them? Observed them in hindsight?
how many things lived only in possibility or until you look directly at them? Perhaps we are all particles in collapse, finalizing into form only when asked, when held, when truly seen. So tonight, as you close your eyes and leave observation behind, know this: there is a world of possibility still waiting, still unmeasured, and somewhere inside the spaces between your footfalls, between your breathing, between your thoughts, the universe listens, because you are watching, because it is watching through you, and what's real is not just what is, but what is seen. Reach out your hand into the emptiest part of space. Grasp the air between stars, the place beyond gravity's voice, beyond even time's pull. And you might believe you are touching nothing, but you are not, because in quantum physics, even nothing is crowded with potential. This chapter begins with a riddle the ancients asked in simpler language. What remains when everything is taken away? In the classical model, the answer was silence. Remove particles, remove fields, remove energy. What remains is vacuum, a blank, eternal stillness. But the quantum world does not abide by stillness. Beneath everything you know, in every direction you aren't looking, in every pocket not yet stirred, there is motion, emergence, conversation. From what appears to be absence,
existence grows. It begins with quantum fields,
the silent bedrock beneath all particles. Unlike the material things they give rise to, these fields permeate the universe.
They are everywhere.
They are indistinguishable from the fabric of space itself. When those fields fluctuate, when a ripple rises like a wind brushing water's surface, a particle appears. Not summoned from beyond, but drawn from within. It means nothingness is flawed. It is textured at the smallest scales. Even when you strip away matter, energy, temperature, light, the fields remain. And they are never truly still. They fizz with primal vibration. A silent orchestra practicing in the dark, warming up before the show. This vibration is not whimsical.
Is it not poetic license? It has weight.
It has law. It is embedded in the mathematics of quantum field theory and arises directly from one of the most fundamental truths of all, the Heisenberg uncertainty principle. This principle tells us there are limits, not based on technology, but on the fabric of reality itself. To what can be known at once, you cannot know both a particle's position and momentum with perfect clarity. The act of defining one blurs the other, and this fuzziness creates a kind of irreducible motion, a trembling that never fully fades. Even at absolute zero, the coldest conceivable temperature, atoms do not go still. They shiver. Because uncertainty refuses to loosen its grasp. It is this trembling, this foundational flicker that ensures the vacuum is never empty. Instead, it seethes with activity, virtual particles, borrowing energy from the void and returning it before reality notices. These flickers are not stable, observable things in the familiar sense. They are mathematical possibilities that exert real effects, altering energies, tugging on the behavior of nearby particles, even affecting gravity's imprint. They are, in every sense, threads woven from nothing, and they make the invisible touchable. In 1948, physicist Hendrik Casimir proposed an experiment that demonstrated this subtle power. Two metal plates placed in a vacuum just microns apart would be gently pulled inward as though by a ghost, but the force came from quantum fluctuations themselves. In the space between the plates, fewer wavelengths of virtual particles can exist than outside the gap. This pressure imbalance nudges them together, an invisible force born not of gravity or magnetism, but of fields unwilling to be still. It's faint, almost undeserved in its subtlety. But what it tells us is profound. That space is not empty. It is not the absence of things, it is the presence of potential. We walk every day upon a floor of unseen scaffolding, quanta not yet observed, fluctuations not yet chosen, paths not yet walked.
These are not mysteries waiting passively to be solved.
They are actively creating the shape of what becomes, and perhaps we too, in some unspeakable way, are woven from this same language, not just made of particles, but of the probabilities themselves. Not patterns over emptiness, but patterns of emptiness. You are not just atoms arranged neatly in skin and story. You are quantum fields vibrating into coherence, again and again, from the smallest scales to this present moment, this breath. It challenges much of how we define the self. You are not separate from the void. You emerge from it.
Every heartbeat a ripple in timeless fields.
Every thought a soft fold in quantum silence. These thoughts, these stories, they arise not out of nowhere, but out of everywhere. And this thread-like foundation of the world, these ghostly pulses in space-time, might even birth more than particles. They may birth space-time itself. Some theories, still forming in the crucible of physics, suggest that dimensions, even gravity, may be emergent from deeper entanglements. That space and time are not fundamental after all, but are woven from quantum connections, invisible links forming a web so rich,
so intricate it gives the illusion of geometry and order. We may not be living in
space. We may be living in structure emerging from information. A universe where
nothing at all becomes everything. We can touch that.
Thought alone is enough to invite stillness, a stillness, not of absence, but reverence.
Reverence for the idea that the very air around you is resonant with unseen chords.
That the darkness is never truly dark. That silence, at its most faithful, is music not yet heard. So tonight, as the world around you quiets, remember, you rest not on cold stone or solid wood, or even atom-packed matter. You rest on threads of becoming. You are carried by echoes of a space that was never empty, cradled by trembling that cannot still, and even when all else is gone, form, light, certainty, still those threads remain, waiting to weave. There is a rhythm we trust without question, the quiet ticking underneath everything, the unfolding of now into what was, morning into afternoon, childhood into memory. We live by it.
Move gently forward by it. But what if time
isn't quite what it seems? What if this river you swim through, that is straight and reliable, is only a surface trick? What if beneath its current, time isn't flowing at all, but emerging? In the quantum world, where the rules of ordinary logic dissolve like fog in warm air, we find that time is no longer guaranteed.
It does not march.
It does not command. It does not even move. It waits. Time at this level does not surge forward in a line. Instead, it trembles, suspended, and in some ways, missing entirely. Unlike the other ingredients of physics, mass, charge, spin, time behaves strangely in our deepest theories. In quantum mechanics, time isn't integrated equally with space. It isn't a dynamic actor. It's a kind of external backdrop, assumed and borrowed, always slipping in from beyond the frame. In quantum field theory, particles dance across regions of space. They gain energy. They interact. But time itself often sits quietly outside the equations.
More a label than a process. At the smallest scales,
Time is not fundamental. And when we attempt to marry quantum mechanics with general relativity, Einstein's great insight into how mass curves space-time, the tension grows. In general relativity, space-time is fluid and shifting. Gravity is not a force, but a bending of time and space together. But in quantum mechanics, time won't bend. It just ticks along unmoved. The two theories treat time so differently. They can barely shake hands. And yet, through their friction, something new is beginning to emerge. There are physicists now who suggest that time might not exist at that deepest level, that our sensation of time, of before and after, of cause and effect, is not fundamental to reality but happens because the macroscopic world filters experience into sequence. In other words, time may emerge from entanglement, from quantum information locked together in complex ways. A sense of before and after could appear, like waves appearing on the sea, not because the ocean flows in one direction, but because something disturbed its surface. As systems grow, the more entangled, complex patterns form. From those patterns, it seems, a kind of clock begins to tick. Not a real clock, but the whisper of change. Not time itself, but the illusion of its passage. And from that illusion, we build everything: memory, anticipation, story. But deeper down, hidden in the dark, lies something astonishing. In dozens of quantum experiments, especially those that use delayed choice or entanglement swapping, we find that future decisions can influence the past, that a measurement performed after a quantum event can still affect how that event behaves, even though it should already have happened. That's not just a philosophical paradox, that's reality acting with unbearable gentleness across time itself. In one version of the delayed choice experiment, a photon passes through a device that acts like a gate with multiple paths, like a maze of glass and destiny. The scientists can choose, after the photon has already moved, whether to observe it as a wave or a particle. And yet, whichever choice they make, belated, delayed, is retroactively honored by the behavior of the photon. As if the future reached back, rearranged the past and whispered, "Behave as though I had always chosen this. What does it mean for time if the past is not fixed? What does it mean for you? You are a being who walks within clock time, the steady metronome measured by rotation and decay. But the truer rhythm, the rhythm of the fabric beneath it all, may not favor any one direction. In some interpretations of quantum theory, the math holds when time runs forward or backward. The equations of nature are time-symmetric. It's only the second law of thermodynamics that pushes the arrow of time. It tells us that entropy, disorder, increases, that sandcastles fall apart, not the other way around. But this direction of time emerges from statistics, not necessity. Entropy explains how memories form, how stars burn, how eggs break but don't unbreak. It feels like law, but it may only be the shadow of something deeper, or the limit of how we observe. And still, there's something in us that clings to the march. We feel aging, we feel loss, we feel the weight of moments that were and the uncertainty of what's to come. Time haunts us not just from clocks, but from meaning. We want the future to be soft and the past to be safe, but quantum physics tells us the past isn't as safe as we thought, and the future isn't forbidden. They are connected, entangled through possibility, and we may be living in the fluid in between. Maybe it's not time that contains us. Maybe we contain the experience of time, moment by moment, like a lotus blooming one petal at a time, though all the petals were always there. What feels like flow is a flickering. What feels like linearity may be a projection and the true engine of change. It may not be time at all, but attention. Our ability to collapse possibilities into moments gives rise to the story unfolding.
And in your life you feel it, not as particles or equations,
but as memory, breath, and choice. Perhaps this is why the present feels so precious. It is the only brief place where then and when obey you. So as you rest tonight, let go of the push.
let time float for a while.
Let past and future fall away. You were never really moving forward. You were swimming in stillness made visible, choice by choice, and sometimes time forgets to flow. Stand before a mirror and raise your right hand. The reflection lifts its left, not because the glass tricks you, not because the laws have failed, but because the physics of symmetry holds. What is right becomes left, forward becomes back, and the self gazes back in perfect opposition. It is one of the most foundational beliefs in science that nature, at its most sacred level, respects symmetry, that the laws governing a storm in one place should operate the same in its mirror image, that particles and fields obey reflections like dancers practicing in palace glass, equally graceful from either side. For a long time we trusted this. It comforted us, knowing that the cosmos played fair. But then the mirror broke, and the universe lost its perfect elegance. It happened quietly, buried in an experiment so subtle most never heard it. In 1956, physicists Tsung-Dao Lee and Chen-Ning Yang suggested something heretical, that perhaps particles might not always obey mirror symmetry, that some events in the subatomic world might play out differently in reverse. To test this, physicist Chen-Xiong Wu prepared an experiment using cobalt-60, a radioactive isotope. These atoms were cooled near absolute zero and exposed to magnetic fields, forcing them into orientation like compass needles. Then they decayed, emitted particles, electrons flying out as small bursts of radiation. In a symmetrical law of nature, those electrons should have sprayed in all directions with no preference, but they didn't. They preferred one side. The mirror had been violated. This phenomenon is known as parity violation, and it turned physics on its head. For the first time, we saw that the weak nuclear force, one of the four fundamental forces, disrespected symmetry. It chose a direction. It favored left-handedness in particle spin, a preference that its mirror image could not preserve. The consequences were vast. Suddenly the universe wasn't neutral at its core. It wasn't a perfect ballet of opposites giving birth to balance. No, it had leanings, subtle tilts, cosmic preferences, and if some laws of physics play out differently in the mirror, what about everywhere else? Matter and antimatter, for instance, should have been produced in equal measure after the Big Bang. They are mirror twins, opposite in charge, equal in mass. Yet as far as we can tell, the universe chose matter. Antimatter all but vanished. That imbalance, known as CP violation, involving charge and parity, tells us the cosmos isn't entirely fair. Not even at the quantum level. Something long ago selected one version of reality to persist, one framework, one flavor of unfolding. Why? We don't know. Some say it's quantum randomness. a cosmic coin toss made once and never again. Others believe it is evidence of deeper symmetry-breaking fields, perhaps tied to hidden particles not yet discovered. Hints of this lie in the foundations of quantum chromodynamics, the theory of quark interactions, and in the never-quite-solved strong CP problem, an unsettling balance our equations seem to predict, but the universe refuses to wear. And still, through all this, there is something eerily human in nature's choice. Because we too live in asymmetry. Our hearts tilt left. Our organs spiral. Our fingerprints whirl in distinct directions. Even our brains split in two. One side dreaming, one side judging. Our molecules twist as right or left-handed spirals, and only one shape nourishes us. Biology seems to remember what particle physics whispers. The world is not evenly folded. There are subtle biases, preferences etched deep in the code. And perhaps they are not bugs in the system. Perhaps they are what allow complexity to rise, and from complexity, life. Symmetry is elegant. But it cannot grow, it cannot make decisions, it cannot choose. Only asymmetry leads to difference. And difference, slight, quiet, barely visible, gives rise to structure and meaning and time. Maybe the mirror didn't break at all. Maybe the mirror was never the architect. Maybe the crack in reflection was the origin of everything. For if particles perfectly mirrored themselves, they might cancel out completely. No imbalance, no creativity, only stillness. But something wavered, something tipped, and in that fracture, reality bloomed. So then, what are we to do with this fallen symmetry? We accept it. We find in it a kind of beauty more alive than balance. And we realize this, that perfection was never the goal. The goal was unfolding. And unfolding requires the courage to prefer, to deviate, to lean left instead of right, to spin up instead of down, to live instead of flicker. Tonight, as you rest, picture your reflection not in glass, but in time, an echo of what hasn't happened yet, a ghost in reverse. Not every version of you must agree. Some paths do not return, and that's all right. Sleep now, cradled in the quiet knowledge that the universe chose this version of itself, this path, this matter, this shape, this sky, and it never once looked back into the mirror. Close your eyes for a moment. In that blink, the world flickers out, and yet you do not vanish with it. Your memory continues, your awareness does not pause. That blink is not absence, it is continuity, draped in darkness. But what if, during that tiny silence in your vision, the universe quietly, split, not tore, not shattered, but shimmered once into two or more? One world where nothing changed, another where you thought something different, another still almost the same, except in that one, the star outside your window didn't flicker just now. What would you call those invisible shifts? What if reality didn't pick a single outcome, but took every path? This is where we enter one of the most mind-bending interpretations of quantum mechanics. Not a theory of particles alone, but of worlds. Worlds layered atop each other like paper, thin thoughts scribbled into space-time, never touching, but all unfolding, all real. This is the many worlds interpretation. When we speak of superposition, the idea that a particle can exist in multiple, possible states at once until observed, we are often left wondering, what happens to the other possibilities? Where does the version go where the electron turns left, not right? Where the cat lives instead of dies, where the outcome, not chosen, still somehow remains. The Copenhagen interpretation tells us the wave function collapses. One reality is born. The others are gone, but Everett's Many Worlds says, no. The wave function doesn't collapse, it coheres into all possibilities simultaneously. It does not decide which reality to become. It becomes all of them. Each path that could exist does. Each decision unfolds in its own branch. Each quantum event spawns a splitting, not an ending, and from this gentle splitting, a forest of universes blooms, infinite, untouchable, each born from the soft math of quantum mechanics, humming below perception. It sounds like science fiction, but the equations support it. In fact, Many Worlds doesn't add anything wild or new to quantum math. It removes the mystical collapse. It just lets the mathematics sing its natural harmony, uncut, uncurled. To some physicists, this is more real than the world you know. Imagine it, an infinite expanse, layered not in distances but in versions. There is a world where you paused longer before turning the page. One where the coffee cooled slightly differently. One where a song you've never heard of became your favorite. One where a meteor landed in an empty field in Kansas, and no one ever knew it missed a city by a hair's breadth. One where you never said the words you regret. One where you did. This is not just a poetic idea for weaving fantasy. In the math, each event in quantum systems communicates as a wave function. No single outcome is preferred until a measurement decides. But in Many Worlds, the measurement doesn't collapse anything. It forces you to split too. The observer, your thoughts, your breath, your memories, entangle with the system. Each version of you perceives one version of the outcome. Suddenly, you're not in the original universe anymore, but in one of the many where your chosen path became real. Not all physicists believe this, of course. The idea unsettles. It asks us to believe in things we cannot touch, to accept that the world we know is only one thread in a cosmic tapestry too wide to comprehend, because we cannot test these worlds. Not directly, they cannot communicate with us. They are not elsewhere in space, they are elsewhere, else how. Their silence is part of their nature. And yet, when you stare at the equations, when you ask them to whisper their truth, they offer this same echo that in the realm beneath perception, even isolation is an illusion. So, if these many worlds are real, wait, what do they mean for you? Perhaps it means that no choice is final. That somewhere you are still walking every road you didn't take. That your unlived lives breathe quietly behind the curtain of this one. And yet, you should not lose yourself in imagined ghosts. Because even if those other selves exist, even if you're rippling through countless variations, this one, the version who sits here now, feels, dreams, sleeps, wonders, this you is the center of your universe. Don't let eternity take today from you. Let it comfort you instead. Let it whisper, no potential is ever truly wasted. No version is lost. Every wish that never came true still finds a home. And maybe, beyond the stars we see, there is a subtle,
eternal recognition, not just of what is, but what could have been.
You'll never walk in those worlds, but they may remember your footsteps. Perhaps it means something else too. That reality isn't binary, not either or, but and also that every moment is a garden of forking moments, and we are flowers, opening into many blossoms at once. Tonight, when you blink, remember the hidden doorway it briefly opens. The smallest gesture contains innumerable possible echoes. There is more behind every moment than we will ever know. More between each blink than the eye could ever see. and the universes that hold them are only ever a breath away. Somewhere beyond fire, beneath frost, past the reach of motion and breath, there lives a limit. Not of size, not of time, but of stillness. It is a temperature not yet touched by nature, a destination we can name but never reach, a place so cold even atoms forget how to shiver. Physicists call it absolute zero, 0 Kelvin or 273.15 degrees Celsius, the lowest possible temperature, where a system has surrendered all its heat, all its vibrational energy. Its motion ceases. Its noise fades, but the truth, as always in the quantum world, is stranger than numbers. Because even this complete absence of heat is not truly empty. Even here, something stirs. At absolute zero, classical physics tells us, the dance of particles should stop. Brownian motion, the jitter of atoms constantly nudged by energy, would finally rest. The particles would lie in perfect geometric stillness, but quantum mechanics denies that. It doesn't allow for perfect quiet. Even when temperature falls away into theoretical nothingness, zero-point energy remains, an irreducible trembling built into the structure of space-time. Because of Heisenberg's uncertainty principle, even at absolute zero, particles retain a flicker. Position and momentum cannot both be perfectly known, so the heartbeat of the atom never completely stops. The universe, it seems, never goes fully still. Even when drained of all heat and light, there is noise beneath the silence. It's in these extreme frontiers that physicists have discovered entirely new forms of matter. Not the everyday solids, liquids or gases we know, but exotic quantum states that emerge only near absolute zero. Take Bose-Einstein condensates. Beautiful, fragile things, cool a dilute gas of bosons to a fraction above absolute zero, and the individual particles begin to blur. Their wave functions overlap, merging into a single quantum state. The many become one. The atoms lose their individual identity and move as a unified wave. It's as if 1,000 separate voices stop singing solo and begin to chant in perfect harmony. Not because they were told to, but because the temperature made it inevitable. Here, at the edge of nothing, a strange kind of unity is born. Bose-Einstein condensates were first predicted by Albert Einstein and Satyendra Nath Bose in the 1920s, but it wasn't until 1995 that human hands created one in the lab. The matter within it behaves in ways alien to classical physics, flowing without friction, defying gravity, dancing to rules all its own. These condensates are delicate, yes, but they are also wise. They reveal that cold is not just the absence of heat, but a doorway to hidden laws. At absolute zero, symmetry breaks in strange ways. Quantum phases emerge. Systems become more than the sum of their atoms. They remember the elegance that higher energy drowns. But still we cannot touch that perfect zero. Not truly, it remains forever out of reach, not because our tools are weak, but because the universe itself defends it. Just as you can never reach the speed of light if you have mass, you can never reach absolute zero with any real system. To remove all energy would require an infinite number of steps. Each attempt can only bring you closer, a decimal here, a decimal there, but never arriving. This isn't failure, it's structure. The laws of thermodynamics place this limit carefully, like a boundary painted around a dream. The third law tells us that as a system approaches absolute zero, the entropy, the disorder, approaches a minimum, not necessarily zero, just as low as it can go. The universe allows sublime stillness, but not total silence, and perhaps in that fact there is something worth cherishing. Because we, too, search for quiet. We imagine peace as the absence of motion, the fading of thought, the stilling of time, but perhaps true peace, like the universe itself, is never a perfect void. Perhaps it always carries a soft vibration, a memory of motion, a pulse beneath rest. Even at the bottom of the coldest reality, something remains awake.
Not loud, not moving fast enough to burn.
But alert, present, aware. It may be that particles, like minds, cannot forget entirely. They remember place.
They carry trace.
They move even when they no longer wish to. The mysteries of absolute zero reach beyond physics into something spiritual, a metaphor for how far we can retreat into ourselves before we find that something
endures, something essential. The deepest rest still carries weight.
The deepest silence still sings. And more than that, these extreme cold states may hold the keys to quantum computation, to superconductivity, to our next great revolutions in understanding matter. Close to zero, electrons pair together into quantum twins. Resistances vanish. Currents flow forever, unopposed. In superconductors, entropy is not chaos, but woven order. And what brings them into being? Stillness, cold, an approach, and never an arrival. So what does absolute zero truly mean? It represents longing, the universe pressing closer to the place where movement ceases, while whispering its refusal to ever truly arrive. And maybe that's what perfection really is. A destination always approached, never held, a kind of sacred asymptote. We chase the quiet not to catch it, but to remember that such a place exists,
even if only in the mind of the cosmos. Tonight, as you drift towards sleep,
imagine not a flame, but its opposite, not a fire-consuming air, but a hush-consuming flame. Picture atoms fading into alignment, collapsing into harmony, until the only thing left is a pale vibration. Soft and solemn, like the memory of sound, and in that place, that grey quiet of absolute almost nothing.
Let even your thoughts fall away. Rest now. The universe is still humming, not cold, just remembering.
Where everything began, there's a story you've been told since the
moment you opened your eyes, or a story written
in clocks and calendars, in footprints and falling leaves. The story says, first comes a cause, then comes its effect. The match strikes, then it burns. The breath is drawn, then released. One thing follows another, like a line drawn across paper. But in the quantum world, the ink blurs before it dries, and the line no longer knows where to begin. This small story, cause leads to effect, is the heartbeat of classical physics, of history, of memory. It's how we navigate the world with any sense of meaning. But there, in the deepest mechanisms of the universe, this clarity begins to dissolve.
And what emerges in its place
is something more fluid, more dreamlike. A world where the future may reach back to touch the past. This isn't philosophy. It begins with photons, as so many mysteries do. Simple pulses of light, traveling not with question, but with purpose. In experiments like the delayed choice quantum eraser, scientists play with causality, gently bending time's arrow to see if it will snap or simply smile. A photon is sent toward a beam splitter. It must choose a path. Then it passes through another system. Layers of lenses and detectors, gates and decisions. But the key lies in the twist. Whether or not we gather which path information, whether we can know which direction the photon took, is decided after it has already traveled. And yet, the results change. If we erase the which path information after the photon has been detected, the interference pattern appears, as if it had traveled all paths at once. If we preserve the path, the wave collapses. No interference arises, but we made that choice after the light had already done its journey. How then could it know? It's as if the photon existed in a liminal state, not simply waiting to be measured, but waiting to be explained. And according to our explanation, it bent itself backward and forward in time to comply. Reality, in a strange way, is not just what happens. It's what can be known about what happens, and sometimes what can be known isn't decided until the effect is in place. In these moments, the distance between cause and effect wavers like heat over black asphalt. It's not that the future controls the past, not exactly, but past and future become part of a larger quantum whole, bound together, forced into coherence only when you ask the question. The cause isn't always the reason, and the effect doesn't always wait politely. The idea itself is unsettling, that time might not be a thread, but a loop, that the present settles not only into the future, but also back into its own origin, echoing until it fits. In the sacred logic of general relativity, space-time is a geometry. It can curl, twist, stretch, and, under extreme conditions, form closed loops. In such scenarios, cause and effect blur in the classical sense, but in quantum mechanics, the loop is not space. It's information, and built into every entangled system is the soft suggestion that knowing here can shape behavior there. And perhaps knowing now can shape behavior then. Can meaning twist backward? Can the story rewrite its first line once the last page is turned? These questions are not metaphors. They are built into quantum theoretical models, such as retrocausality, where backward-in-time influences are part of the formal architecture.
Not science fiction.
Not time machines. But the bold idea that what feels like a linear arrow of time may actually be a flowing field, more like memory than like math. And you live in the middle of it. We talk about the past as fixed. We say you can't change what already happened, but every time you recall a memory, your brain reshuffles it, deletes some colors, emphasizes others. You unknowingly write a new version and seal it back up again. What, then, is the true cause of your behavior? The original event, or the most recent memory of it? In dreams, cause and effect rarely hold their shape.
One moment becomes another without transition.
Events ripple forward and backward without concern for rational order, and yet meaning remains. Perhaps quantum mechanics, too, is a place where logic sleeps and meaning dreams forward. This strange flexibility doesn't mean life is chaos. It means life is subtle, that the rules of the deep universe aren't revealed with answers, but with questions. What outcome do you seek?
What knowledge will you gather?
According to your intent, the quantum world responds, not because it is watching, but because possibility collapses into outcome through the narrowing of understanding. And maybe this very phenomenon lives in your mind. You choose, you change, you reach backward without knowing, reinterpreting each past moment based on who you've become. You are not the same person remembering
As the one who lived it, and in this way the past is not fixed.
just named. The reality of now is not the end of the story. It is still folding, still adapting, still humming along the strange,
Tangled thread that stretches not in one direction,
but across all directions at once, recording what could be. Tonight, as you lay down, let this possibility sink in, that today could be the cause of a new beginning hidden somewhere in your yesterday. That the smallest action, smiling when you're tired, forgiving when you're hurt, doesn't only shape the future, but reaches backward, softening a harsher path that once led you here. What if healing travels not forward, but inward? What if time, like the universe, listens not to clocks, but to coherence? Sleep now, wrapped not in sequence, but in harmony. Let the boundary between before and after dissolve, and let the next moment rise, like a question you've already answered. Imagine a speck, invisible even beneath the sharpest lens, Now imagine that speck refusing to be still, not because it's fidgety, not because something pushes it, but because the rules of the universe deny it stillness. This is the electron, not merely a particle, not a marble spinning around an atom's core, but a wandering whisper in a probabilistic maze. It is there and not exactly there, always somewhere, but precisely. We live in structures built from matter, from atoms tightly bonded, from shapes we trust. We speak of the periodic table of configurations and molecules, but at the heart of all that substance, it is this one ghost-sized being that moves in quiet chaos, and every time we try to understand it, the rules shift again. Electrons obey the laws of quantum mechanics, not classical force and edges, but waves of probability. When confined within atoms, their positions do not sharpen, but blur. They do not orbit like moons or circle like satellites. They dissolve into clouds called orbitals, not physical loops, but regions of possibility. An electron may be close, it may be far, it may spin up or down, but it never fully is until you attempt to measure it. And when you do, the wave collapses. One option survives. In that moment, you catch reality choosing itself. To speak of electrons is to speak of confinement and motion coexisting, of particles behaving like waves,
of duality real enough to be the backbone of chemistry, and strange enough to still leave physicists in awe, and yet.
Electrons are also essential to everything you can see. The flicker of light does not strike your eyes without their motion. The nerves that carry thought through flesh do so because electrons leap across ionic borders. Every spark, every signal, every shimmer is born from their flow, and they are always flowing, even in silence, even in rest. A metal bar, left untouched in the dark, still hums with the shuffle of electrons. When cooled near absolute zero, they may arrange into patterns, moving without friction in what's known as superconductivity. But even then, their movement is nearly perfect, not stopped. One cannot stop what was never static. But their strangeness doesn't end with motion. Electrons hold spin, a quantum property without a classical counterpart. Not rotation per se, not spinning like a top, but something deeper. An intrinsic form of angular momentum. A label the universe tattooed onto the particle at birth. This direction, not that one. Spin gives rise to magnetic fields. It orders the electron into a kind of symmetry or antisymmetry when joining others. In truth, the entire structure of atomic assembly, the very chemical identity of elements, depends on how electrons fill up orbitals, dictated by spin, one up, one down. Always obeying the Pauli exclusion principle, which simply says no two electrons can occupy the same quantum state in the same place at the same time. This, too, is why matter has structure, why atoms don't collapse, why materials are solid. It is their dance, not chaos, but pattern that we live inside. But even more breathtaking are the experiments that ask, where is the electron when you're not watching? In the classic double-slit experiment, electrons fired one by one through the slits still form an interference pattern over time. It's as if each electron passes through both slits, interferes with itself across space-time, and only later chooses which place on the wall to land. Now imagine this. These patterns, this proof of electron wave behavior, only appear when we are not watching closely. When we set up a detector to find which slit the electron passed through, the interference fades. The whole story changes. This tiny particle, the electron, seems to sense your curiosity, or at least it reshapes its path in response to your inquiry. What does that mean? Some whisper that consciousness plays a role. Others say it is the interaction, not awareness, that ends the superposition. But whatever the mechanism, it is certain the electron is not a silent object. It reacts, it responds. It follows not a pre-written trail, but a branching set of options that mark themselves only when crossed. These paths, all of them, form the labyrinth, and no maze we've ever built rivals the complexity of this one. Electrons also entangle. Two particles once connected behave as one, even when separated by oceans or galaxies. Alter one and the other whispers in tune, as though the walls of space had never been there at all. For the electron, the labyrinth is not distance or direction. It is all the possibilities that space and time can hold. And just one reality is chosen like a thread pulled through cloth when attention demands it. So what are we who are built from this? We are creatures of branching possibility, of paths collapsed from particle clouds. We think we choose, but perhaps each thought is an electron choosing too. A movement, a spin flipped this way or that, a gate opening in a neuron, a spark that defines the present. You are not separate from this maze. You are made of it. Each bone, each breath, each blinking moment is a layering of choices you did not notice. Of tunneling electrons, and yes, they tunnel too, appearing on the other side of barriers they technically should never pass. But they do because the labyrinth was never made of walls. It was made of probability, guided not by intention but by the symphony of what could be tonight.
As you lie in stillness, think of the one electron humming inside you,
Passing through organelles and thought alike, untouched, untraced, but inevitable. It obeys no obvious path, no script you can write, no trail you can walk. But it leads you home all the same. The labyrinth does not trap. It invents. So sleep now, dear traveller, and float gently between the branches the electron never chose,
and the one beautiful path
that made you imagine a universe in total darkness, no eyes to receive the light, no sensors, no cameras, no minds curious enough to ask, would it still exist? Would the stars still shine, the particles still spin if no one, nothing, ever looked?
It's a question so old it feels like a riddle from ancient temples.
Whispered not at chalkboards but in dreams, and yet quantum mechanics forces us to ask it again without metaphor, not with mysticism, but with measurement. What if nothing becomes real until it is observed? This idea is whispered across every quantum experiment, but nowhere is it clearer than in the famous question, what is the state of a system before observation? And the clearest answer we're given is this: it has no definite state at all. It is not just that we do not know what the particle is doing. It is that, until we ask, the particle itself does not know. It exists as a wave function, a haze of probability, mapping every possibility like piano notes not yet played. The particle is in all possible positions, all paths, all spins, all states at once. And only when we look do those possibilities collapse into a single reality. You don't receive a pre-written answer. You write the answer by the act of asking. To witness is to choose. To observe is to reduce likelihood into fact. This collapse isn't like the sound of falling. It isn't violent or visible. It's a quiet sifting of the universe, saying yes to one version
and no to every other. It is strangely creative and beautifully disturbing because it means the universe may not be a fixed story, but a living page.
blank until read. This phenomenon was first interpreted as a kind of duality between the quantum world and us, but it goes deeper than that. The act of observation means more than just seeing. It means interaction, measurement, entanglement, any mechanism that forces the universe to settle, to decide. We measure. The wave function collapses, but here's where the mystery deepens. What triggers the collapse? Is it the machine?
The equation?
The consciousness? Different camps have different answers. The Copenhagen interpretation says reality is a cloud of possibilities. Measurement reduces the cloud. The many worlds, Interpretation denies collapse altogether. The universe simply splits. All outcomes happen. You've followed one branch, but others, like consciousness-based interpretations, whisper a more fragile truth. That awareness itself may be fundamental, that the observer is not just someone watching a show, but a participant, co-writing the script. This leads to questions science isn't yet ready to answer. What is the role of consciousness in the physical world? Is it emergent or elemental?
Might it be
The very force that completes the quantum dance? It would mean you are not witnessing the universe. You are causing parts of it to become real, not through willpower, not through belief, but by being connected to the act of knowing. There are no stunning explosions that come with this transformation, no shock waves of energy. But something subtle unravels. The idea of a world existing independent from the act of interaction begins to fade. Reality becomes participatory. Now, pause, let that settle. If the fabric of the universe responds, if it folds from possibility into clarity under observation, then every act of attention becomes sacred. Looking is sacred, listening is sacred, even remembering becomes sacred, because every focus shapes the field of what is. Just like collapsing a wave function, your observation of self, of suffering, of sky, pulls one line from the web, one thread from the loom, and suddenly,
this is not about magic.
not about bending the world to whims. The moon does not vanish when you close your eyes, because other things are still engaged with it. The air, the ground, the photons still bouncing toward distant matter. Observation doesn't require the human mind alone, but your mind is one of its instruments. You participate in sight, and through that sight, whether with eyes or attention or question, the surface of the quantum world folds inward. Some quantum physicists, like John Wheeler, took this far enough to suggest the universe is a participatory phenomenon, that at its root, reality is less like a static object and more like a conversation. There may be no such thing as a thing, only processes that involve a knower. He once asked, does the universe exist if there is no one to observe it? But in the heart of his thought was something warmer. No phenomenon is a phenomenon until it is an observed phenomenon. Reality, in this view, isn't brute fact, it's relational. It's built not from objects but from interactions, from questions asked and answered. Measurement isn't passive, it's constructive. In a way, we are living inside a grand, subtle act of attention, and maybe so is the universe. Tonight, as you close your eyes, think of the way your awareness gathers, how you brush your perception across the moments of your day, selecting memories, giving them space to bloom. You are a quantum participant. You collapse yourself from all the possible versions of today into the one that sings here now, and yet all the other versions, unseen, untouched, drift like stardust into the spaces between seconds. Choose not with fear, but with reverence, for where you place your gaze, the world unfolds, and where observation becomes creation, so too do you. There's an old feeling, older than science, older than song, the feeling that something has stitched reality into shape, that space has form, that matter stays where it belongs, that the world is real and won't suddenly ripple apart beneath your feet. This is how we live, in the quiet assumption that reality holds. But beneath that feeling is something unexpectedly delicate. At the quantum level, there is no such thing as solidity, no such thing as isolation. Even position is borrowed from uncertainty. Matter is a suggestion that collapses into temporary shape, bound by relationships in data, not in material walls, and yet it holds. What keeps a chair together? What keeps your mind from scattering into all the thoughts you could have but didn't? What is the thread that keeps dreams from melting into entropy? It is coherence, or rather, the illusion of coherence, born from entanglement, from interaction, from thermodynamic direction. But deep down, this coherence rests on a strange and ghostly edge, as if everything we see is a shimmer on the surface of an ocean deeper than form. Let's begin small. Take a single system, say an electron bound within a hydrogen atom. It occupies a quantum state. It does not orbit like a mini-planet. Its position and momentum blur into a shape across the atom's potential. But remove that system from interruption. Cool it, isolate it, shelter it from information exchange, and it can remain coherent. It can stay in this suspended state of superposition, all options flickering at once, but the moment the outside world touches it, when chaos or observation or stray
energy leaks in, that coherence
disappears. The illusion of quantum stillness collapses. This is called decoherence, the process by which quantum systems lose their fragile ambiguity and collapse into observable states. Not because we measured them directly, but because they became entangled with their surrounding, like a whisper lost in wind. The world around us is in a near constant state of decoherence, collapsing and resolving. Every moment of isolation is fleeting. Every particle exists not independently but in quiet correspondence with the infinite noise of everything else. So what happens when many entangled systems remain coherent long enough? They create order. They give the illusion of a stable world where electrons find shells, atoms form lattices, molecules hold shape, and thoughts arise from delicate arrangements of electric fields and neurochemical patterns. Without coherence, this symmetry breaks. Without the illusion,
matter melts. Yet the illusion is not false, it is simply emergent. Like the way heat from countless jostling particles appears as smooth warmth.
like the way the ocean becomes calm, even while each wave is madness, the illusion that holds everything together is not a trick. It is an agreement, a sustained pattern of entangled relationships, stable enough to become experience. And yet, at any moment, new noise can interfere. Quantum computation, our attempt to harness superpositions at scale, fails not because we cannot build qubits, but because coherence fades under heat, vibration, and attention. It fades unless guarded. And this fragility, the fact that being coherent is hard, is what gives our world its shape. If quantum ambiguity persisted too long at large scales,
reality would fall apart. Cats would stay half dead.
Particles would refuse to land. Every action would forever multiply into every possible outcome. The world would be a smear of uncertainty, but it isn't. Why? Because coherence collapses easily, because interaction happens constantly. Matter decoheres so quickly and thoroughly that classical-like structures dominate, and so we live in what feels like one world instead of many. We see fixed events instead of flux. We remember, because memory, just like the physical world, requires coherence. It is stability across time,
A scaffold built from repetition, from structure.
from patterns that held just long enough to be written into biology and mind. But here is the beautiful secret. Stability is built from impermanence.
Order from illusion. Nothing holds forever. Every molecule is slipping.
Every structure is a momentary truce.
And the fact that you're here now, breathing, resting,
Dreaming, it means billions of quantum coincidences have managed for now to hold hands. You are the structure they made, the illusion they've held. And your experience of now may be just that, an elongated moment of extremely rich coherence,
stringing together particles, emotion, awareness.
before dissolving into entropy once more. Some physicists say the arrow of time itself may be born from decoherence, not a deep law but a tendency, Systems evolve into states that give out more information than they take in. They decohere, they move forward, and so do we. Coherence may be temporary, but while it holds, it sings. While it holds, it builds bridges between possibilities and chooses roads across tangled fields. While it holds, you live inside a self that feels continuous, a mind, a memory, a name. And when it fades, whether in sleep, in silence, or decades from now, we do not vanish. We dissolve into the deeper possibilities from which we came. We return to the field, to chance, to shimmer. So tonight, lie gently down within the arms of this fragile illusion, this globe of impossible coherence. Let its brief grace protect you, not because it's absolute, but because it chose, for this moment, to hold. And for now, that's enough.